All right, in this short demo, we're going to show you how to convert Kaggle's G-Research Crypto Forecasting Competition into a Kubeflow pipeline using the open source Kale JupyterLab extension. All right, for the purposes of this demo, we're picking up where the last one left off. So this is going to assume that we've got a couple of prerequisites already taken care of. The first one is that we've already set up our Kaggle credentials via a Kubernetes secret using a pod default. Also, we're going to assume that you've already launched a notebook server. In this case, we're going to reuse the one from our KFP SDK demo, where we had 8 virtual CPUs as well as 16 gigs of RAM and 50 gigs of storage configured. We're also going to assume that you have git cloned the Kubeflow/examples repository. All right, let's go ahead and connect to the notebook server. And from here, we'll want to navigate to examples, locate the G-Research Crypto Forecasting directory, and then open up the Kale-specific notebook. The first thing that we're going to need to do is to do a pip install of a variety of different dependencies that we need that are specified in our requirements.txt file. And once those dependencies are installed, we're going to want to restart the kernel. So let's go ahead and do that. And once the kernel is restarted, we are ready to enable the open source Kale JupyterLab extension. And you'll see that located in our sidebar. We'll simply toggle over to enable, and we can see that various cells in the notebook are already annotated for us. For example, our first cell grouping here are imports. The second cell grouping here are pipeline parameters. You can see that's the annotation that we're using to specify those parameters, which takes us to our first pipeline step, which is going to be the download data step. You can see we're using the pipeline step annotation. Same thing here now with our second step, which is going to be the load data step. We're going to go ahead and use that pipeline step annotation and specify that it depends on the download data step. Then we've got 2 groups of cells here in the notebook, and both of these are going to be annotated as functions. That takes us to our third pipeline step, which is going to be the feature engineering step. So here with this particular step, you can see we're using the pipeline step annotation, and we're showing that it depends on the load data step. This takes us to our next pipeline step, which is the merge assets and features. You can see that's a pipeline step annotation, and it depends on the load data as well as feature engineering steps. This takes us to our next step, which is the modeling step. And you can see we're using the pipeline step annotation, and it depends on the previous step. And it takes us to our final step here, which is going to be the evaluation result step. You can see we're using the pipeline step annotation, and we're specifying that it depends on the modeling step. We also conclude the notebook with 2 pipeline metric specifications, and these are going to be the metrics that we're going to want to see in the UI at the conclusion in the run output. All right, so with that, we are ready to run and compile this pipeline. So the first thing that Kale will do for us is validate the notebook, take a snapshot, and then it's going to compile the notebook, upload the pipeline, and run the pipeline for us. So let's go ahead and click on the view hyperlink. This is going to take us to the runtime execution graph where we can watch our pipeline execute in real time. You can see that we've created a volume. We're now downloading the data. Then we move on to our third step, which is going to be the load data step. Then we move on to the next step, which is going to be the feature engineering step. And once that completes, we're ready to move on to the merge assets and features step. And with that step complete, we move on to the modeling step. And with the modeling step complete, we move on to the evaluation and results step. And that's it. You've actually run your pipeline. So let's go ahead and double click on the result step. And like all the steps that you see here, you're going to get input and output information, visualizations, volume information, logs, events, as well as artifacts. Now let's go ahead and click on over to the run output. Remember, we were looking for 2 things. We were looking for the root mean squared error as well as the weighted correlation. You can also move from a simplified to a more complex graphing of your pipeline. But that's it. You have successfully created a Kubeflow pipeline for Kaggle's G-Research Crypto Forecasting Workshop using the Kale JupyterLab extension.